Hello, I'm DNS Kaushik, 19BC 1363. Today I'm going to explain about Euler's theorem and Fermat's theorem. And before going to that, let's see what is Euler's torsion function. Euler's torsion function is defined as phi of n of any positive number n which is greater than or equal to 1 is defined as the number of positive integers less than n and that are co-prime to n. So the meaning of co-prime is like when you take two numbers, there should not be any common factor other than 1. So when you take phi of 3, the answer is 2 because here we want to check the number of positive integers that are less than n, and that should be the co-prime to the given number. For example, 1, 2 are the co-primes to 3 and they are less than 3. For example, when you take phi of 14, the answer is 6. Because when you take the numbers from 1 to the 13, all the numbers are below the 14, and we should check whether they are co-prime to 14 or not. So when you keep on checking them, you will see that 1, 3, 5, 9, 11, 13 are the co-primes of 14. So the answer is 6. So let's take, so now if the n is a prime number, then phi of n is equal to n minus 1. For example, when you take phi of 13, the answer would be the 12 because n equal to 13. So n minus 1 is 12. So you can also manually check about this. Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All these numbers are co-primes to 13 because all these don't have any common factor other than 1. So phi of 13 equal to 12, and this satisfies for every prime number. So let's see if m and n are two co-prime numbers, then phi of m into n is equal to phi of m into phi of n. For example, let's take phi of 15 is equal to phi of 3 into phi of 5, because here 3 and 5 are co-primes. So on solving this equation, like phi of 3 is equal to 2 and phi of 5 is 4 and 2 cross 4 is 8. So phi of 15 is equal to 8. Let's see another example. If a number can be factorized, then it will be represented in this form. It is the prime factorization of a given number. Then n equal to p1 power e1 into p2 power e2 into p3 power e3 and so on to pn power en. Then phi of n equal to n of 1 minus 1 by p1 into 1 minus 1 by p2 and so on till 1 minus 1 by pn. Let's take an example and see how this works. So let's take n equal to 36. This 36 can be factorized as 3 square into 2 square. So here the p1 value is 3 and p2 value is 2 and e1 value is 2 and e2 value is 2. So by substituting in the above equation, n value becomes 36 and p1 values become 3 and p2 value is 2, and 36 cross 1 minus 1 by 3 into 1 minus 1 by 2. So that is equal to 36 into 2 by 3 into 1 by 2. So by calculating this, we'll get 12 as answer. So the phi of 36 is equal to 12. Now let's go into the main concept, that is what is Euler's theorem. So here Euler's theorem is defined as if n is a positive integer and a and n are co-primes, then a power phi of n is congruent to 1 mod n, where phi of n is called Euler's torsion function, which we have seen previously. Let's take an example and verify like whether this Euler's theorem is satisfying or not. Let's take a equal to 8 and n equal to 165, and here GCD of a comma n should be equal to 1, and GCD of 8 comma 165 is 1. So phi of 165 can be written as 3 cross 5 cross 11. So all these numbers are co-primes to each other. So by solving this equation, we'll get 80 as the answer, and phi of 165, the answer becomes 80. And here by substituting this 80 in the above equation, that is a power phi of n congruent to 1 mod n, we will get 8 power 80 is congruent to 1 mod 165, and a power phi of n t is congruent to 1 mod n, where t equal to 1 comma 2 comma 3 and so on. So this is the general equation of Euler's theorem, and this is the special case, or which can be called as Fermat's theorem also. Like a power phi of n of t plus 1 is congruent to a mod n. Here n is a prime number, then phi of n becomes n minus 1. So when you substitute this value in the above equation, the phi of n when t equal to 1 becomes a power n minus 1 plus 1, which on simplification becomes a power n is congruent to a mod n, and this is called Fermat's theorem. Thank you.